So in this video, we are going to continue with our Mod 3 exam review. I think it says maybe exam 3 review problems on your iMath calendar. So open that up and let's talk about problem number 3. It says a box is formed by cutting squares from the four corners of a sheet of paper and folded up the sides. The graph below shows how the volume of the box in cubic inches. V is related to the length of the side of the cutout square in inches. So we know that our points represent an X, which is the cutout side in inches, and V is our volume in cubic inches, okay? So the point 0.75, 30.938 that's shown, oh no, it's a new point, so watch what your point is. This means that when the volume of the box is the Y value, 30.938 cubic inches, then the cutout length is 0.75. So whatever yours happen to be when they mention the point, okay? Now in B, it says when the cutout length is 2.25 inches, the volume of the box is 25.313 inches. This means that the point is what on the graph? Now remember, the inches is our X value, the volume is our Y value. So by taking a moment to write this down at the start is really helpful, okay? So it really helps us relay what's happening. So that is what they want for B. Now, C says, suppose the largest possible cutout is 3.5 inches. Over what interval of X does the volume of the box decrease as the cutout gets larger? So it says that suppose the largest possible cutout length is 3.5 inches. So what that means is that over what intervals X does the volume of the box decrease? So if our X value is at 3.5, so it doesn't match that point very well, but if our highest point is 3.5 and then we're going downhill, okay, we would want to know what this value is. The X is from here to here. So if this is 1.3, in this case, mine would be 3.5. And it looks almost like this is just a bit more than double that. So that looks to me like it's a value, I don't know, like somewhere about 7.2. So my point is totally wrong, but they say that it goes from 1.3 to 3.5. Oh, okay, no, wait. Let's go back. Now I think I understand what they're telling us. Suppose the largest cutout length is 3.5. So that is where the volume becomes 0, because as soon as we do it, that's the largest thing we can cut out. So that's why it decreases from an X value of 1.3 to an X value of 3.5. Okay, I'm so sorry, but there we go with that. So that is that, and adjust yours accordingly if they've given you different numbers. So that's question 3. We're going to skip question 4 and 5. Please jump to question 6. Now, in question 6, it says, consider a circle whose size can vary. Let R represent the radius in centimeters. So again, have a sheet of paper out, write down what they've told you. And C is the circumference. And that is in centimeters as well. Now, the circumference of a circle is 2 pi r. So that's a formula you should know. The area of a circle is pi r squared. So know those general formulas for a circle. Okay. Let g be a function that's determining the radius of the circle in r. So g of r, given its circumference c. So g of c would equal r. So we want to rearrange the equation here so that we can plug in c and get out r. Okay, so let's take this equation and let's solve it for r. We want to solve it for r. Okay, so we know r would equal c divided by 2 pi. So this would be c divided by 2 pi. Now make sure when you do c divided by 2 pi, you either use that fraction bar or you do c divided by parentheses 2 pi. And you can type out the word pi, or you can use that little yellow box to find a pi symbol. So g of 13, okay, so we know g of c equals c over 2 pi. So g of 13 means when the circumference is 13, the radius would be whatever that 13 divided by 2 pi is. So this is the radius when the circumference equals 13. So that would be this first one here. So g of a equals 13. Remember, the output of this function is radius. So say g of c equals r. So this is the radius is 13. The circumference is g of a. So what does a represent? A would be the circumference. So a is our circumference. So that would be this one right here. So the circumference is the g of a. The radius is 13. So that's a little bit about that problem that we see there, problem number 6. Now let's jump to problem 7, our good old volume problem. Now always note what your paper is. Mine is 9 by 12. So you can take a sheet of paper and put in 9 by 12. You can draw yourself a little rectangle. So this side would be 9 minus 2x. This side would be 12 minus 2x, and this would be x. So the volume of that box is length times width times height. So length would be 12 minus 2x. Width would be 9 minus 2x. Height would be x. So length times width times height, or width times length times height, any variation of that will get you that. So a function of x, they want you to rewrite it just one more time. Now please note, mine is a 9 by 12, so that's why I have 12s and 9s. If you have something different, that's fine. Okay. The domain. Look at our our smallest side is that, mine is 9, whatever your smallest side is, okay, of the original size of the box. The most you can cut out, so the x's, the largest x I can cut out, will always be half of that. So it can be anywhere from 0 up to half of that value divided by 2. Or in my case, 0 up to 4.5. You put them in brackets because I could cut out nothing. I could cut out 4.5. Now my volume is 0 in both of those spots, but still it is something I could do. So it is a legitimate answer. Now let's think about the range. The range for this, you want to put that into Desmos, okay? So at this time, I'm going to open up Desmos, and I am going to put in this equation, just this portion right here, okay? So 12 in parentheses, 12 minus 2x, then in parentheses, 9 minus 2x, and then an x. Okay. Now you can tell it that we only want values between 0 and 4.5. Now you don't have to do this portion, but what it does is it does narrow it down for you. But remember, we only care about values between 0 and 4.5. So we really only want this bump. I'm trying to scooch in for you. We really only want this first bump, and we are looking for the lowest to the highest. The lowest volume is nothing. The highest volume is that number you see there, that 81.87. So you have to use Desmos to find range. So the lowest volume is nothing. The highest volume will be the peak. The volume is your Y value. So it's 81.87217. Okay, so they will want you to use Desmos on the test. You will be allowed to open up Desmos, but nothing else. Either iMath or Desmos, that's the only thing I should see on your screens. So there's problem 7. Now we're going to skip number 8. I want to go to the candle problem, problem number 9. It says we have this candle that's 14 inches. Now note, mine's 14 inches, yours might not be. It's burning at a rate of 1.3 inches per hour. Yours might be a little different than mine. So the function is going to be that the height of the candle at any particular time is 14 take off 1.3 t. That's for me. So that's the function they want here, minus 14 minus 1.3 t. Yours might be a little different, okay? In this context, domain, how much time does it take before our height is nothing? Well, take your 14 minus 1.3 t and look at when is it going to hit the height of nothing? When's it going to hit a height of 0? So that's going to give us our domain values we want. So if you solve that, you get 14 equals 1.3 t, or how many times does 1.3 go into 14? So 14 divided by 1.3 is, I don't know, 10.76923. So in this particular context, my domain value, time nothing, time 10.76923. And you could even probably put in iMath 14 divided by 1.3 for this section of your domain. Now you want those in boxes because at the 10.76923 time, we do hit a height of 0. It is a legitimate answer. C, what is the range? Now you can put that formula in, but you have to know what domain you're looking at. At time 0, my height is the highest, 14. At time 10.76923, my height is at the lowest, 0. So range always goes from least to greatest. I can have I'll end up with 0, but I start at 14. Now, if yours isn't a 14-inch candle, but it's a 15-inch candle or 17-inch candle or whatever, it would go to 0 to 17, 0 to 15, 0 to 14, whatever that case may be. Now, f of t equals 6.6 means that the function equals 6.6. Now, adjust yours if it's different, adjust it accordingly, but just solve that. So I would subtract 14 from both sides. 6.6 minus 14 is, in my answer, negative 7.4. Divide by negative 1.3. So I get an answer of time being 5.692308. So 5.692308. And that, remember, represents hours. So if we look at the question in E, for part D, what does it represent in this context? It is how many hours it is when the candle has burned for, or it's 5.69 is the hours, so the 6.6 was the particular height at that particular time, so that's why it's this one. So it's hours. So if you know that time represents hours, it would be how many hours since the candle was lit when it is 6.6 inches long. Okay, so there's question 9. Please just adjust if your numbers and my numbers are a little different. Now let's jump to question 10. As it says, a tank with some water is being, or begins to drain. The function is 50 minus 2.5 t. It determines the volume of the water in gallons. So we can say that V of t is equal to gallons after a number of minutes t. So t is in minutes. So what is the vertical intercept? Remember, vertical intercept is a fancy way of saying the x-intercept. It is not, I'm sorry. The vertical intercept is a fancy way of saying our y-intercept. I think a vertical line goes up and down, the y-intercept goes up and down. Sorry. So that's our y-intercept. So our y-intercept is the nice one. We just get to plug in 0. So in this case, it's v, so it's v of 0. So it is 50 minus 2.5 times 0, or 50. Now, if your function is 40 minus 2.5, 30 minus 2.5, it's that 40, 30, 50 in this case. What does your answer represent? Well, that means at time 0, so that would be the 0.050. So at time 0, there is 50 gallons. So it would be the number of gallons of water in the tank at the start. So that's this first. So that's the number of gallons in the tank when it starts. Horizontal intercepts or roots, those are our x-intercepts. So in that case, we have to find where the function equals 0. So write down your function, set equal to 0, and solve. Now sometimes there's more than one, that's why they put intercepts or roots. If there's more than one, separate them with commas. So we're looking for x values, in this case, t values. So we're going to solve 50 equals 2.5t. 50 divided by 2.5 is 20. So it is 20. They should be of the form 20, 0. So at the 20-minute mark, we have 0 gallons. So what does D mean? So it is how many minutes it takes for the water to drain. So that would be this one. Okay. So that is how many minutes it takes for all of the water to drain from the tank. So when the volume is nothing. Okay. So that is problem number 10. Okay, let's jump to problem number 11. It says, consider this function. What is the vertical intercept? Remember that is just your y-intercept, so you just get to plug in 0. So if we plug in 0, that's 5 times 0 plus 8 minus 5. Now, just follow order of operations. Don't make it harder than it has to be. That would be 5 times 8 minus 5, or 40 minus 5, or 35. Now, the horizontal intercept is usually harder mathematically. In this particular case, write out your function. Anytime they say horizontal intercepts, set it equal to 0. Now, what are we going to do? We're going to add 5 to both sides. You can distribute the 5 at this point if you want, so let's do that. You could have also, because both sides are divisible by 5, feel free to divide by 5, doesn't matter. You get that 5x equals negative 35, so x equals negative 7. Now, B has a slightly more complicated problem, but they're nice to you. They did go ahead and they factor it for us, which is always great. So remember, for B, we're going to plug in 0 for those vertical intercepts. So we get 0 times 11 times 13, which is just 0. But in part 2, it's harder because we have to actually set the function. So you're going to write down your function, set the function equal to 0. Now, when it's in this factored form like that, it's really great because we're just going to set each piece equal to 0. So whatever your equation is, whatever factored form it is, pull out each factor and set it equal to 0. Don't forget the 0, okay? So we get 0. This one gets to become 11 equals 2x, or x equals 5.5. This one is 13 equals 2x, or x equals 6.5. And so just list them, 0, 5.5, 6.5. Because there are 3 different individual factors, if none of those factors are a complete match, you should expect 3 different answers. So expect some questions like that on the test. Let's look at 12. It says, 2 relationships between x and y are shown below. Relationship 1 is represented by the blue solid graph. Relationship 2 is represented by the red dash graph. And they're asking, are they functions of x or are they functions of y? So let's do the functions of x first. So we're going to see, are these ones true? Okay. If it is a function of x, so if y is a function of x, it has to pass the vertical line test. Okay, so let's go ahead and make some vertical lines. For the blue function, relationship 1, the vertical lines I draw only will ever hit the graph once. So relationship 1, is y a function of x? Yes. Okay, let's look at those vertical lines again. If we can even find one that hits the graph more than one spot, like look at this one. You see how it hits it twice? That is not a function of x. So this one here, relationship 2, y is a function of x, out. That doesn't work. Okay. Now let's go the opposite way. Is x a function of y? That needs to pass the horizontal line test. Okay, so now let's draw some horizontal lines. So you can see that the horizontal lines only ever hit our red one once. So that's true. But they hit our blue function multiple times. So this one is out. Okay, so the only one that's are true. Y, the blue function, y is a function of x. The red function, x is a function of y. So know this rule, and then you're good to go. Now let's look at 13. It says determine the domain and write your answer in interval notation. If you see a fraction for part A, you're just going to set the denominator equal to 0, solve for that. That's the value and the only value that we skip. So you can see the answer down here. But that means, see how there's a skip at 2. There's no hard bracket on the 2. So that means I can go from negative infinity, up, come up to 2, skip it, up, keep on going. And you are going to have to use that little yellow box to write that. Now, for B, it is a square root. Just take the inside, set it greater than or equal to 0, and solve. That is any value greater than or equal to negative 3. So on the number line, I can have any values from negative 3 and to the right to infinity. That's why our bracket is on negative 3. We go to infinity. So that is why we see the answer down here. Now, C is a combination of those things. Okay, so we're going to do both things separately. We know that the denominator, x minus 2, is not allowed to equal 0, so that's why we have to skip 2. See how they skipped 2? But we also know, so we're going to break the word and, that x plus 28 has to be greater than or equal to 0, so solve that. X has to be greater than or equal to negative 28. So on the number line, both things have to happen. Put those values down from least to greatest. I can be negative 28 and bigger, but I have to skip the 2. Do you see how it's in 2 parts? So I am at negative 28 until I hit 2. Got to skip it. Keep on going. So that is why our answer is that. Let's look at 14. Using function notation to represent the following. Okay. The cost in dollars in 2008. Now, the function says that f of t is in dollars. That is the cost of the car, the Honda Accord. T is years since 2000. So if I want to write the cost in dollars of a new Accord in 2008, that is just my function 8 years after 2008. If I want to compare the cost in 2013 compared to the cost in 2010, it's just the ending minus the beginning. So f of 13 minus f of 10. A new Accord in 2013 is how many times as expensive of the Accord in 2010. So that is just the function at 2013, so 13 years later, divided by the function at 2010, or 10 years later. You may need, if you don't use the little yellow box for your input, you may need to put parentheses around those things. Be careful. Now, in D says, it's $620 more than the cost of the Accord in 2017. So the cost of the Accord in 2017 is f of 17. We have to add on 620. It's $620 more than the cost. So add 620. So that's all they're looking for 14. So it's very helpful as you're doing these problems, have a sheet of paper and write down what do those function things mean. So then you're able to reproduce the function notation. So that is problem 14. Now let's look at number 15. It says using the graph to show function f, evaluate f of 1. So when our x value is 1, the question is what is the y? That's all that's saying. So when our x value is 1, what is our y? Do you see how it's down at negative 2.5? That's all they want. Now, B, we're going the opposite direction. When our y value or our height is 2, what is our x? So find a height of 2. What is the x? The x is 4. So that's what they're saying in part A and B. Now, the vertical intercept is just where does it hit the y-axis? Remember, that's our y-intercept. So you'll see it hits it at negative 4. What are the horizontal intercepts or roots? That would be right here. Now, the 2.5 line, it's just after that. So let's go 2.7. They're going to say, if anytime they say estimate. Now, if this graph was squiggly and it hits it more than once, include all of those values where it hits it, okay? This is a linear function. It only hits it one time. So there's problem 15. We're going to skip 16, 17, 18, 20, 19. Did we do 19? Yep, 19 and 20. Skip all the way down to problem 21. It says we have some function h. It started out being function f and g. Please note, whatever function's closest to the x, f of x is your inside function. G of x is the outside function. So I always go that what's inside, what's outside. Our inside function is that simple thing inside, in this case x minus 3. Our outside function, think about if it were written more of a simple x inside instead of x minus 3 or whatever's inside. That is what our g of x function would be, 1 over x to the 7th. Okay. You might want to use that little yellow box to input an actual fraction. That might be a little easier than trying to type out what they want there. Now, there is more than one answer to this. That's, I think, the simplest way to think about it. Let's look at 22. Okay, let's see if I can scooch in a little bit. Okay. So our first one here says, find g of f of negative 1. So we're going to start from the inside and work our way to the outside. So f is the red, no, f is the blue function, g is the red function. So f of negative 1. When x is negative 1, our f function is at a height of 1. So that would be now g of 1. Now, the next thing we're going to start with, if x is equal to 1, what is our g function doing? When x is 1, our g function is at a height of 1. So the answer is 1. Now let's do B. So start with your inside g of negative 1. So at negative 1, our g function, which is in red, is at a height of 1. So that would be f now of 1. Now, the outer function is f, so now we're going to go to the f function, which is in blue. When x is 1, our blue function is at a height of 3. So our answer is 3. And then finally, f of 0.5. You'll notice how this time we're going to use the f function twice. So if x is at a value of 1/2, our f function, I believe, is at 2.5. So that's f of 2.5. Now we're going to go back to the f function. We're going to find an x value of 2.5. I would say it looks about 4.5. So that is how we use a graph to evaluate a composition. Start from the inside, work your way to the outside. Now let's look at 23. It says evaluate f of 6. You're just plugging into the function. We're plugging in 6. Be careful, watch your order of operations. If I plug in 6, I get 6 squared, write that down, plus 13 minus 5 times 6, so that's minus 30, over 7 times 6, why not do it? You know, some of those pieces you can do in your head or in a calculator. And then 13 minus 30 is negative 17, so that's 36 minus 17 over 42. 36 minus 17 is 19, so that's 19 over 42. I think just putting 19 divided by 42 is a good option because iMath will then give you that preview of that weird decimal you see there. Okay. Now, B says to input g of x plus 3 into the function, and they're going to want you to simplify it as much as possible. Well, no, they don't ask us. They don't say the word simplify. Let's not simplify. So every place we see our input of x, take out, put a parenthesis of x plus 3. So that'd be 3 times x plus 3 squared minus 6 times x plus 3 plus 9. If they say the word simplify, you do have to FOIL that out and then distribute, you know, you have to distribute. But since they didn't, let's just leave it alone. And then they said for C, input 3x, they did not say to simplify. Okay, so that's going to be, wherever we see a y, put a parenthesis, and then we're going to stick in our input, which is 3x. So that'd be 3x cubed minus 6 all over 8 times 3x. So please use maybe that little button on the side to write that fraction out nice and pretty. So that's 23. We're skipping 24. And I believe, oh, no, so we're skipping 25. Let's jump now to 26. 26 says that we want to find these values. Okay, so we're going to use our g function first. So focus on the g. We're going to input a 6. So that's going to be g of 6 is the square root of 12. Now that's just a number. Don't care. Okay. And now we're going to stick that square root of 12 into our f function. So now we're going to do f of the square root of 12. So it's going to be the square root of 12 minus 4, the quantity squared. Now they want you to input a number. Try to see if you can enter that on the line, if it gives it to you. But if not, if you actually put that into a calculator, you get 16.186,414.05. Okay, so that is just inputting, follow your order of operations, put negative 12 into F. Oh, we're putting negative 12 into F. Did I do that right? Negative 12 into F. Wait, let's do that. I'm sorry, I only did the first one. What if I've lost my mind? I'm sorry. The answer would be, okay, stop. I put 6 into G, I got 12, square root of 12, and then put that into there. And then if I put, this answer is so not right. I don't know what they're talking about. Okay. And then if I put F into square root of 12, I get that. Let me tell you what that is. The square root of 12 minus 4 is negative 0.53. Oh, it is, okay. And then square it. Okay, there it is. I'm sorry, I've lost my mind slightly. You do get 0.287187. Okay. But I wonder if you put this in, if it just would give it to you. You can try. Okay. Now, I didn't do the next one. Sorry. Now we're going to start and we're going to plug negative 12 into our f function. Okay. Negative 12 minus 4 is negative 16. If you square that, you do get 256. So that's 256. So now we're just going to put 256 into the g function. So g of 256 is the square root of 262, which should be that 16.186414056 number. Okay, sorry about that. That was a little bit messed up, but I think you understand what. So plug 6 into G, get a number, plug that number into F. Plug negative 12 into F, get a number, plug that number into G. So plug 6 into G, get a number, plug that number into F. Plug negative 12 into F, get 256, plug that number 256 into G, get the square root of 262. I think you'll be able to put that into there. Okay. We're skipping 27. Now please jump to 28. It says define a rule for the inverse. See, it says just f of y. So all we need to do is make y equal 5x minus 11 and solve it for the opposite variable. Solve it for x, you're done. Okay. So it should be y in your function. So we're going to add 11 to both sides, divide by 5. So our new function would be y plus 11 divided by 5. Now, in B, we want to rearrange it to solve so that we have a function of p. Okay, so let's make it that p equals 2m plus 9 over 4 plus 18. I just rewrote it, equal to the variable they talked about, p. And then I'm going to solve for the opposite variable. So let's just solve for m. First thing you got to do is subtract 18. So we're going to get p minus 18 equals 2m plus 9 over 4. Now the next thing I would do is get rid of that 4. If it's dividing on the right, it'll be multiplying on the left. So if we multiply all of that by 4, we get 4p. Well, they don't. They just write it as a, hey, I'm going to multiply. Oh, we could have multiplied. Okay. And then they subtract the 9 from both sides. So that quantity minus 9 would equal 2m. And so m would be that junk all divided by 2. And that's what we want to put on our line. Now be careful if yours and my numbers are not the same, but it's a similar procedure. Now we're going to skip 29. Please jump to 30. Just seeing where we got to go here. Let's jump to 30. So it says find f of 3. So when x is 3, what is our height? The answer is 1. And here actually our y is 2. We are looking for the corresponding x. That's what that inverse notation says. So when our height is 2, our corresponding x is 4. When our height is negative 2.5, so here, when our height, actually I would say that's 2.5. Our corresponding height is about, let's see, I'll do it again. Okay. So when our height is negative 2.5, so there's negative 3, there's negative 2.5. I think it hits it pretty good. That's negative 1/2. And then here, we don't even have to do the math. These two, if we see their opposites, it's always the answer you see right there. So that's 371. And that's why it does say you can drag the graph around, but you don't really have to, because if those two are next to each other, the x became the y becomes the x. They cancel each other out. They're inverses. Okay, we're skipping 31. Please jump to 32. Oh, no, we have one more. I'm sorry. Okay, so jump to 32. It says f of x such that determines y in terms of x. That is just the function that you are given. But if we want to solve the equation for x, just write that equation down on your paper and solve for x. So we would subtract 13 from both sides, divide by 4, and so you could just put y minus 13 over 4. If you don't want to use the little iMath thing, put that y minus 13 in parentheses. So g of y is just y minus 13 over 4. Which of the following are true? So it says f and g are inverses, okay? And so we could write it with that inverse notation in either order, doesn't matter. And then if we think about what an inverse does, it undoes the process. So all of those would be your option. And then finally, skip that one, go to 34 and 35. We're almost done, I'm so sorry. Okay. Determine the average rate of change of f over the following intervals. So our ending is 16, our beginning is 13. So we have to calculate f of 16 and f of 13. If you plug in 16, you get 23. The square root of 23. 16 plus 7 is 23. If you plug in 13, that's the square root of 20. I believe you could probably just make iMath do the math. It's the ending f value minus the beginning f value. But it is the number that we see right there. So your preview should be 0.107898, so on. Okay. Now from B, okay, stop. I'm so sorry. They didn't just want the change in f, they want the average rate of change. I'm not done. Okay. So it is the change in your f values divided by the change in your x values. I'm so sorry. So you should put this over 16 minus 13, which is 3. So I would just put this in parentheses over 3. That should have been the decimal 0.107898, blah, blah, blah. Okay. So for this one, it would be f of 16.02 minus f of 16 over 16.02 minus 16. F of 16.02 is the square root of 23.02 minus the square root of 23 all over 0.02. And that's what needs to go here. That should be equivalent to that decimal there. And then 35 is just the difference quotient. So anytime they use that x plus h notation. So we're going to do f of x plus h minus f of x all over h. So we're going to do 5 times x plus h squared plus 9 times x plus h minus 13 minus in parentheses, our original function all over h. So let me do that for you. X plus h squared, guys, You guys, some of you are not squaring that right. That's x squared plus 2xh plus h squared. Know that by heart, please. So that's 5 times x squared plus 2xh plus h squared plus 9 times x plus h minus 13 minus 5x squared plus 9x minus 13 all over h. Now I'm going to distribute, okay? So I get 5x squared plus 10xh plus 5h squared plus 9x plus 9h minus 13 minus 5x squared minus 9x plus 13 all over h. Now if I did it right, everything that does not contain a h should cancel. Okay, so 5x squared, negative 5x squared. Yay. Positive 9x, negative 9x. Yay. Positive 13 and negative 13. It just so happens that everything that's left has h's. That's a good indication we are right. So 10xh plus 5h squared plus 9h. I'm going to divide an h out of all of them. So we're going to get 10x plus 5h plus 9, which is the answer that you want to enter in the box. Now, if your function is different, you just have to practice doing the difference quotient. You can look at old notes. Please, to study for this test, do this again. Can you repeat it yourself? Look at old notes, videos. Please look over vocabulary. But there you go. That is our review for the test. Test is Wednesday.